Hello, welcome everybody. This is a talk about machine learning. This title is a little bit bold, isn't it? We can agree on that, like redefining machine learning. So let's work it out. My name is Michal Harakal. I work for Deutsche Telekom. And since we are already living in the AI age, I have a helper today. It's the battery man. And the fans of a Matrix trilogy can know why. I'm going to tell you a story how I was building machine learning framework. And the story began in the kitchen. Almost 3 years ago, I went down on the floor and I found my teenager son baking a pie. I was surprised because he never did it before. So I asked him, what are you doing? Oh, I'm baking a pie. And which one? The lemon pie. Okay, I like it. I like the taste. And actually, where did you get recipe from? And what he did, he put out his mobile phone and proudly showed me ChatGPT with the recipe. Luckily, it was a pie, not a mushroom recipe. In this case, hallucination would probably get a different meaning. But in the moment, I have realized that AI is here. However you name it, however you have a look on this, is something what I have to deal with. I have to understand this, and you can do it best way as engineers do it. You are going to build this by yourself from scratch. So if you cannot create and not understand it, you cannot. If you cannot build it, you don't understand this. This is something what Richard Feynman has told. And speaking about famous people inspiring me on the journey, another one is Andrej Karpathy. And this almost 2 hours long video where he's explaining exactly what I wanted to do, to build small LLM model from scratch. Who doesn't know Andrej Karpathy? He was the grounding lead of OpenAI. He was AI director at Tesla. He was responsible for computer vision in Tesla. And now he's doing like cool stuff for education on the internet, for example, with videos like this one. And he's also famous for to be coined the term vibe coding. What he was building a small ChatGPT-2 level kind of model, really small one with about 10 million parameters. And his implementation consisted only from 250 lines of code. And I think, we developers, as humble as we are, 250 lines of code, I can eat it for breakfast, right? So let's do it. What I didn't realize, really understood, he was using PyTorch. PyTorch is a heavyweight library for machine learning and AI. If you want to build something like that, maybe it's a good idea, okay, have a look on the video, but really understand what this GPT, what these transformers are. So it's something what we are going shortly look on. All the LLMs are based on transformers, and transformers was architecture which was published about in the year 2017, mostly by Google engineers. It looks like maybe like a nuclear plant schema. It isn't so complicated. And the story why I am telling you this is that it was Google with its amount of engineers, scientists, and resources who created the paper, but it was a small company, OpenAI, which has profited from this. So this is something we can keep in mind. If we can create something which is available for people, we don't have to be big. On my journey to implementing something like this, there was some shortcuts which makes my implementation or my learning journey simpler. The first thing is that the ChatGPT-2 is decoder only. So from this huge image, we can deal only with the right part. If you have a look deeper on the picture itself, it's like only 2-3 kinds of rectangles. And if you have a look on the one which is bluish one, we will see this is something what we already seen before, like normal deep neural networks. And in this case, there are the dense one. As the name said, neural networks consist from neurons. And the name is something similar to what we really have in our brains. According to last studies, there is about 89 millions of neurons in our brain, consuming like, I don't know, 20, 30 watts in energy, comparing to 300-400 watt NVIDIA GPUs running in their computers. And they are very simple. They have inputs which react different way on the values, which are weighted by coefficient, by weights. So for example, you can imagine that x1 could be light and x2 could be sound. So your brain is reacting on very strong sound, maybe stronger, as on a little bit more higher light. So every input have a different impact if and how neuron is firing. All these weights and inputs are summed together, and since this is just an introductory talk, I promise I stay only with summation, addition, and multiplication. On the end, our result is going through the so-called activation functions, and this is our auxiliary help to make a neural network be capable to run. Neurons can be put together in neural networks. We put them into the layers, and we connect the neurons from the previous layer with the neurons in our equivalent layer. This kind of network is called dense neural network, and the one you can see on the picture has two inputs, has one hidden layer with 3 neurons, and has 1 output. So how the running or execution or inference of such a neural network works? We do the calculations. We have a look what is the impact of every input on every neuron. So we have a look on A1 is getting the values from x1, x2 is the same one, x3. And what we are doing is just doing the sum, multiplication, and additions. If we put all together, we will learn that we are doing matrices multiplication, something you are familiar from your school. Quite easy. Matrices implementation, matrices multiplications are very important in the whole journey. How could we implement very simple, very naive implementation of matrices multiplication in Kotlin? Just a few nested loops, and I can already hear why less and no double arrays, you're right. We can improve on that too. And for example, make our implementation more friendly, for example, on JVM, to use single instruction, multiple datas, CPU registers to execute our code more efficiently. You can see that we are doing the data conversion to double arrays. We can see hoisting, and we can see that we are rearranging the loops. Maybe engineer in myself would say, oh, it does sounds like premature optimization. But the matrices multiplication are very important. According to this study, in this concrete model, it's about 81% are general matrices multiplication, and it's something where it matters to optimize. This is a sample of activation function called linear rectifier, and it's just delivering the input value if it's higher as 0. And of course, here's a lot of room for optimization. I have mentioned with our first small optimization that we are moved from list of doubles to the double arrays. And in order to understand that, how the data structure used in the computations for machine learning and AI are organized. Mathematically, we are working with tensors, and actually everything we know, or okay, not everything, but the important data structure are just the tensor. Scalar, vector, color image, or multiple color images. They are just tensors of different ranks. What we want to achieve is to find mapping of our tensor structure into the linear memory. So we can store that in the linear buffer. And there are some different conventions how you can do that. And for example, for picture, there is usual having multiple pictures stacked piled over each other. So we are processing image and you're using the capabilities of a modern computers at once. So you are starting with batch, then you can have a color channel, the row, the width, and the height for the columns. And this can change depending on the machine learning framework you are using. Normally, you don't have to deal with this internally because if you are one framework, you are still using the one. And if you need it, of course, there's always the methods for change. So we learned a little bit about feed-forward. So we got the idea how our transformer are doing at least the part of the computation. This is a sample of, let's say, the real neural network. I will show this later in my demos. And this one is very simple. One input, 2 hidden layers with 16 neurons, and 1 neuron as the output. And if trained properly, what this network do, it can approximate sinus value, depending on the training, from 0 to pi divided by 2 quite accurately. You will see this in the demos. Here is Kotlin again coming very handy because you can write and having this tensor and having this operators overloading implementation on place, you can define your inference using the linear as the very simple one-line expression. Just you do your matrices multiplication, of course your inputs has to be transposed, and you are adding your bias. If you do the naive implementation like this, and this is regular working code, you will see that in instantiation of every module, you have to be careful as the number of input values has to be the same one as the number of output values from the previous, so they can match. This is really error prone and happens many times to me, you are getting exception, and this is really hard thing to tackle. And we know Kotlin is known, this is Kotlin code, but this is not nice, not conscious, not easy to read. We can do better. And we have, of course, domain-specific languages for that. And the builder patterns uncovering this DSL language, for example, can deal with this problem, the matching the numbers of output and input layers for you. So you don't have to take care if writing the two numbers together. If you want to learn really transformers, and you will find out that there is the different framework and so on, maybe it is a good idea. I didn't do that on the beginning, but let's try to be objective and find out maybe there is something where I can fulfill anyway my learning journey, but I don't have to write a complete machine learning framework from scratch. And the reality is not so good as you would expect. There is a lot of languages, a lot of frameworks, the bigger one, the smaller one. I'm getting almost every week, like hints or find by myself, new languages dealing with topic, but every of them is focusing only on one area. Either you are dealing with heavyweight science-based machine learning libraries like Tensor or PyTorch, or you are dealing with really low-level hardware libraries trying to get as optimal as possible your networks running on device. But there is really hard something in between, and if you focus on running AIs and models on device, it's even worse. And this is a real problem, not as my understanding, but for example, on the sample of the company Modular, they created a completely new programming language called Mojo, which is designed, it's Pythonic, it's like subset over Python to attract existing developers, but on the end, it's really new programming language in order to achieve optimal performance and easy to write code to be run efficiently for the AI. And there are also already really well-established compiler and tools chains like MLIR and LLVM. I guess some of you are already also familiar with Onyx. I also wanted to mention the programming languages. For example, Halid is the one which really specializes on picture processing and doing it really efficiently, asynchronously way with kind of structured concurrency. So this one is really, okay, we need new programming language to deal with this. Julia is very popular in academia. A lot of PhD students are using this, and of course, they are having libraries for machine learning, and good thing is they're also using MLIR and LLVM compiled chain. How it is on Android? 2 weeks ago, there was a nice message on the Kotlin Slack, which is very useful, by Mkashi, and he was describing his journey to implement. I wouldn't say it's simple. He wanted to build Android application on regular device to scan codes, and this is like what you will see in the article, and he allowed me to use it like it is. It's a lot of stuff and a lot of small prints to make existing model to run on your Android to use hardware efficiently as you need it for these kind of devices. So lessons learned is not so hard, it is not so easy. Despite Google is doing a really good job, especially if you are focusing on device AI. In November 2025, they announced the new version of Google Coral NPU in version 2.0. And what they did, they opened IP property, intellectual property for chips manufacturers to implement their own neural processing unit to be able to do matrices multiplications efficiently. And what the cool is, they are using MLIR and LLVM for conversion, optimization, and compilation of the neural networks code running on the target hardware, naturally, natively, for example, on their own NPU, using IRI runtime. This is also another technology. So imagine we have a choice and we can decide which language we would like to choose, if not the existing one, or maybe the existing one, for something like we want to implement our neural machine learning framework. So I would say this language should be modern for the first. So I probably wouldn't start with Fortran. Maybe Fortran is cool, but I wouldn't say it's really modern. I really would like to have language which is type safe. Then one which is handling very well concurrency and asynchronous programming. And the dream will be if it's multi-platform. So modern, type safe, coroutines, KMP, or modern, type safe. I guess I heard it. And you are right, we have already this kind of language. And it's called Kotlin. And Kotlin is the language for AI. And this is what I really believe. And there are some reasons for that. We already learned about using the DSL. We, of course, know that using DSL combined with tape safety, we can define and combine our networks type safe. For example, I can exactly define that the decoder which is running on the NPU is using integer 8 data types, but the way it's used for the feed forward could be float 16. And you will get the support from the compiler. Of course, concise readable syntax. About coroutines, we don't have to talk. And what is really cool, and this is like hidden part of being the part of Kotlin ecosystem, you have all these compilers, you have KSP, you have ability to write compilers plugin to do some magic for you if you are progressing with your code. And multi-platform is really cool. So from very the beginning, every implementation started to be multi-platform, supporting all existing platforms we get. WebAssembly system come later as it appears. So what does it mean to write AI machine learning framework from scratch. We have seen a lot of libraries, a lot of frameworks, and maybe we can take some learnings, I wouldn't say some mistakes they're making, I would say let's have a look what they're doing well. And on very beginning, what we designed was like multi-layer architecture. So we are starting with definition of our network. Then we do compilation, and then we want to run it somehow. So what does it mean, definition of your model? It could be different ways. We have a look little bit detail on the data model definitions. And on the end is, again, very simple Kotlin DSL. All the code you are seeing all the time is valid, compilable Kotlin code. And having this type safety, I can exactly define my tensors, my matrices, their shape, their data types, and so on. Compilation is a tricky part, but it's the most important part of the whole chain, because in every step you are able to do some kind of optimization. For example, if you define your linear network, your one layer with the neurons, and you add the activation function to that, the current implementation consists from 2 modules. If you print it out, you will have like 2 modules, and the very first idea will be, let's put it together as a one, to do this kind of optimization. Also, the other way of optimization is we are very heavily relying on existing toolings. And LLVM is something which is using everybody. Julia, C-Lang for Apple, Google, and also Kotlin compiler native is using LLVM extensively. What about execution? This is something which is still evolving. I was spending quite too much time on eager execution, especially on the JVM platform. And eager execution means that you execute your neural network as a code as it is defined. So we write your matrices multiplication, and you can like step through, step in, see your variables. You can do some magic optimization, as we've seen for matrices, to get it running, and you are getting immediately the output. This is good for evaluation, for testing, for development, but it's really hard to get best performance from this approach. The main trick, what we are doing, we are using the tape recording approach. So we are kind of like mock executing our network. We are recording every operation with reference on the values during the time. And from this linear representation, we can execute it immediately, or we can create compute graphs. And you know, having compute graphs, you can convert them to almost anything. And having these immediate steps, you have, again, a lot of place for optimizations. And this is what our compiler really good in. So here again, we let the cool guys to do this job. And on the end, we want to get somehow to it run. The first one is to export it as the IRE runtime environment. Or what we also have, and this is quite a good idea, is to generate C code. For example, for very small hardware like embedded controllers, 8-bit Atmels, 16-bit Atmels, to doing, for example, computation like sinus approximation you've seen earlier. So we talk a lot about how and what we can implement it. And this is something what I've spent my last 3 years. And I know naming is hard. It's named SKaiNET for now. It's like progress name. And there are meanwhile 3 different theories. Where does it come from? So the fans of Terminator movies will guess a little bit the darker nature of the name. I was born in Slovakia, so maybe this SK and SKaiNET is Slovak, or maybe it's just simple Kotlin. I let it on you to which one story is better for you. And do we really need another machine learning AI framework? I don't know, but I'm just kind of stubborn and I work on that, and I believe that there is a need, especially focusing to bringing AI on devices. I'm not really going too deep for reason why do you want to run your own AI, like having the digital sovereignty, having control for the version of the models you want to run, having control when and how is your energy consumed, having the privacy solved, having the latency issue solved. For me, what's most important, I have a technology in my hand, which is Kotlin powered, with doing some experiments, knowing that it can work. So we started the project. And on the beginning, I didn't do it very often. Maybe you should start generally with the plan, what are we going to do, and how it will look on the end. And this is something which was created very early. And I'm still sticking with the picture, and if you have to take the decision, and maybe sometimes it's like, oh, maybe we can do something else to add another feature. No, this is the way to go, and it makes easy to take decision. And this picture describes exactly what it is. The Skynet, the library itself, it's only the small one on the left side. So we have some IOs for reading the GGUFs and TAFE sensors Onyx files, the one you can find on the Hugging Face or for the internet with pre-trained weights. We have some classes, data for definition of models, DSLs. We have implementation of tape recorder, so you can already do and run some stuff. And we have all the stuff around these graphs, directed acyclic graph. And the trick and the main benefit or main simplicity coming from this is you can export what you have created in Kotlin into the stable HLO. This is a dialect version of intermediate machine learning language defined as a standard by MLIR project, which itself is just sub-project from LLM. And I can tell you that every major chip producer is working and taking part, implementing code, particularly for this project and also for the ED runtime. And also we have another path with code generation, for example, generate C code and compile it and run it on the small Arduino natively. What does it mean about project this way? You cannot do it alone. This is something probably you want to share. So also from very beginning, this project is open sourced. And meanwhile, I am also, for example, getting help from my colleagues from company. I'm for Deutsche Telekom. They are helping me to get this project being open source compliant by using different libraries. What does it mean to develop this kind of project? Usually, you are either Android, Kotlin developer, and you have really good skills in Kotlin, and this is something which is very helpful. Or maybe I wouldn't write that I can Python, because maybe machine learning engineers can also the other languages, but we have like these kind of two words coming together, and one of the first ideas was we have to somehow come together. And the solution for that is called Dark. It's a shortcut for document, access, research, and code, and it is exactly as described the roles and tasks which are helping to people focus on stuff we can help with. For example, if I'm a machine learning engineer, I am good with Python, I'm going to work research, prepare, look for papers, prepare some code implementation which can be used for the Kotlin. Of course, then you need to write some Kotlin code, and documentation is also a very important part of the project itself, because the complexity of the scale, you cannot just read the code. It's really hard. And what we are using is the Antora-based ASCII-doc structured documentation, so we will find at least the initial versions of getting started documentation, and also some more deep technical explanation how stuff works and stuff doesn't work. How we want to make sure that stuff we are writing in the Kotlin really works. Like we have learned that matrices multiplication is not really so trivial. How to make sure? So the first idea is to have some kind of unit test. And as it is in unit test, you need some kind of truth, some base level you want to compare to. And for this, we've created another small project. And this one is using Python and PyTorch, because in this case, our data scientists can write test suites and scripts in order to define what we have to and want to implement in Kotlin and what are expected results. So this is like one side of project. I imagine you are adding implementation for new operators, like we need matrices multiplication for quantized Q4 smaller model. So I would probably start with implementing just PyTorch implementation, make sure that my multiplications are right. So I'm quite quick, so we can start with demo. And I have mentioned that SKaiNET is multi-platform. So I will show you a few different ways. What does it mean? Multi-platform. The one is, no. The one is your sinus approximator you are already familiar with. And because SKaiNET is Kotlin multi-platform, using all advantages the Kotlin is providing, so it's a really simple application built from KMP wizard, running in browser as WebAssembly, running on Android, and running in JVM. And this application, what it's doing, it's visualizing. Okay, I have to move the window, not the application. And what this is doing, it's just with the slider, you can emulate the input value, and the green one is the value what the trained network can deliver. And now you see it's not working because network hasn't been trained yet. So you are, with the growing input, your error value is also growing. But we have this small button here, so we can say, start training. And because this is a smaller network, running on my device, it was quite a quick. And now you can see, if I update again values a little bit, that maybe my trained network doesn't perform perfectly. And this is, again, it's not about the implementation of library, it's about how you define your architecture, how you train, how many times you train, what are your labels you are comparing your results to, and so on. But what we have seen now is in Kotlin DSL defined small neural network running on the device as a part of application, can be trained and can be deployed on JVM, Android, and I can also show the same thing with the browser. So again, I'm going to start training. This is this time running in the browser. There is no backend. Everything can run offline until you say, okay, the page has been loaded. And again, you can do the same thing here. Having the same UI as a shared component, and you can see the performance. Maybe there are some, no, that should be the same. So we are getting, again, neural network with 2 hidden layers defined with Kotlin DSL, trained in your browser. And probably you already heard, we have Kotlin notebooks, which can do the same thing as a part of your environment. And this is also something I want to show you. And so what you can see, we have a cells, and every cell can be either regular Kotlin code or Markdown to create some documentation. And we can execute one after another as normally you would do in this kind of interactive environment. And as you can see, the Skynet cuts already little help also from the JetBrains. So now the integration of the library itself is so easy that you write just use Skynet minus notebooks, and you not only get the all important library loaded in your Kotlin notebook environment, it's also taking care, for example, if your notebook is running with the vector API available from Java 21 and upwards, you can utilize the power of this. So we are also loading some existing cool libraries from JetBrains for visualization and plotting, some imports, and maybe this is the most interesting part for you. This is a real definition of the real network. So you can see again 2 hidden layers with 16 neurons. I have added them explicit names. I've loaded the weights, weights of biases already from the file, so I don't have to train this one. And if I execute this, it's just model definition. Then I define my execution environment. In this case, it's eager one, so I can execute it immediately. And what I'm getting as a result, I can see and compare the results and values for every emulated approximated input, and having beautiful Kotlin libraries for visualization and plotting, I can also plot. And in actually there are 2 lines, but they are so accurate that you see only the one. So we have learned about my almost 3 years long journey to implement machine learning library. We have learned how Kotlin is useful on the journey, and we also learned that it's not so easy. So maybe you think it's something good I can help with. Of course, like contributing, asking for issue is actually the most perfect way how you can help the project. Come to me with your issue, with idea what you want to get running on device. And I believe that we as developers, because we are now living really these crazy AI times, maybe you can say exciting, I said crazy for a reason, and I believe there is also a little bit our responsibility in which direction we are going. So maybe everything is just unicorns or rainbows in the future, or maybe we are ending as the batteries for AI and robots in the future. So it's up to us. Thank you very much, and I guess we have some time for questions.